All right, join me on page 176 in your science book. This is chapter 3, lesson 2. We're going to be learning about waves, different types of waves. So again, page 176, let me fix that right here as well. 176 in the science textbook. Okay, here we go. What is a wave? Kinetic energy always moves. Wind blows, water flows, light travels, and electricity passes through wires. How does energy move from one place to another? Waves and energy. One way that energy moves is through wave motion. Drop a pebble in a pond, and at first, only the moving stone has energy as it falls. Then little waves pass over the pond's surface. Another example of energy. A few moments later, a leaf at the edge of the pond bobs up and down as the wave reaches the shore. The waves have carried some of the energy from the dropped pebble across the pond to the leaf. A wave is a disturbance that carries energy from one place to another without a net movement of matter. That means that as a wave travels through water, the water moves up and down, but it doesn't move in the direction of the wave. The wavelength of a wave is the distance from the top of one crest to the top of the next, or from the bottom of one trough to the bottom of the next. A wave's amplitude is the distance from the midpoint to the crest or trough of the wave. So you can look at the picture on the bottom of page 176. You can think of wavelength as the length of the wave and amplitude as the height. That's kind of like the height of the wave. Okay, moving on to page 177. Follow along. Measuring waves. Waves can be measured in different ways. Water waves move up and down. Sound waves move back and forth. The back and forth or up and down motion of a wave, sometimes called a vibration, is described by its frequency. The frequency of a wave tells the number of vibrations it makes in a given period of time, usually 1 second. For example, if 2 vibrations occur in 1 second, the frequency is 2 vibrations per second. Okay, turning the page, we're on page 178. What is sound? Toss a pebble into a pond and the ripples spread energy outward from where the stone entered the water. Strike a drum and the air around it ripples outward in waves too. Like other forms of energy, sound travels as waves. A sound wave is produced by the vibration of an object. A sound wave carries vibration from the vibrating object outward in all directions. For example, a drum produces sound when the drum head is struck. A guitar produces sound when a string is plucked or strummed. In a saxophone or clarinet, the sound is produced by a vibrating reed. The sound of your voice is caused by vibrations of your vocal cords. The pitch, or highness or lowness of a sound, depends on its frequency. A high-pitched sound, such as that from a flute or a whistle, has a high frequency. The vibrations that produce high sounds move back and forth quickly. A low-pitched sound, such as that from a foghorn or tuba, has a low frequency. The vibrations that produce low sounds move back and forth at a slower speed than those that produce high-frequency sounds. Hearing sounds. How do we hear sounds? Sound waves from one vibrating object can cause other objects, such as your eardrums, to vibrate. You may actually feel a very loud sound, such as a gong, vibrate inside your body or against the soles of your feet. However, most sounds are detected only by our ears. The human ear is so sensitive that it can pick up the tiny vibrations in the air that we hear as sounds. And you can see the diagram below on page 179 is showing the inner workings of the ear and how it works. And just in case you were curious, in my left ear, the reason I can't hear in my left ear is that the eardrum from my ear has been removed, and the ossicles, those three little bones right behind the eardrum, that those vibrate, which take sound information to the cochlea. But I don't have an eardrum or ossicles, so that's why I can't hear out of my left ear. All right, thanks for watching, and I'll see you on the next one.